So far, I gave you 3 demos, but does it mean anything? From our knowledge, it doesn't mean much if we don't do statistical study. And in this, what I want to show you, the next slide, okay, and you look at this slide, what you have is, in my left hand side, is I select about 150 eyes of the person. Then I'm running randomly, select this, crop and select and run it, and we have a database about 2000. Okay, and when we run it, the exact match is about, we recall exactly 100% correct. Okay, no problem. But about the similarity match, it about 448 case, it recall correct similarity. So it's about 96%. Right? And now, in mouth and nose, we do the same thing with 150 and same exact match, we have 100% correct. But the similar match, we have only 85% correct. Okay? And depends. Maybe the information right now, my conclusion why it have some kind of discrepancy, we still don't know. But I believe based on this study, our partial face recognition is very reliable, very robust. Okay? But remember in this case, with a single partial input, our technology able for the first time to retrieve, interpolate the correct and relevant object. That's what it's on about. But in this, I just show you that no scaling here, no scaling. Okay? But let's see how the scaling on about. Okay, now, so far we only show you no scaling, but in the real world we're dealing with is the object when the database phase, the database object, it have some kind of discrepancy about the resolution and about the scaling issue. Okay? And now, in the left hand side, over here, I show you if it no scaling, that's the first file, how it looked, the picture. You get the picture. With the random scaling, you see the resolution, it changed. For example, from this to that, it's about 49% of the one in the bottom is 49% of the top one. Okay, and you can see that on the scaling issue in the play here. Okay? But also, I want you to look at the random scaling we use in study for 100 random image. It's ranking from 0.4 to 1. That means 40% of the resolution to 100% of the resolution. That means completely identical. Okay. Now we run this and see how it's performed with the scaling issue here. We run the 100 case, and for the base match, yeah, we have about 100% correct. Okay. That's for the no scaling. And the similar match, we have about 86% correct. Okay, with no scaling. But now go to scaling, random scaling, we go from 100% correct to 98% correct. That means it decreased about 2%. And for a similar match, from 86% correct, it goes to 81% correct. And what I try to show you in this is the scaling, it decreased, but it's not a lot. So what I'm telling you, our scaling invariant approach is sufficient to deal with the scaling problem from the real world application. Okay? And now the next one, I also want to show you, so far you may question about, I have only 2000 images in database. And now, in order to show you about more data, see how it performs. And we don't have a big database where what we use is the movie, okay, to demonstrate whether how good our algorithm dealing with the big database. Here is in the movie an official and a gentleman movie. I just extract randomly one face of Richard Gere. Okay, he is single input, only single. So far we talk about single. And we input into the ADC search engine along with the movie in here as a database. Okay, then we run the movie with this single input image, and I try to find it can find any similar person in the movie. And here is a sum of result over here. Okay, and you see, given this, and we have on what we found here, just part of it, and totally we found 195 similar objects, okay, based on the only single input image, and it makes no mistake in here. Okay, but from this study, what we learn is with our algorithm able to dealing with certain rotation, okay, and also dealing with the scaling, okay, the scaling issue. So now, given this, if it's able to detect some scaling and rotation of the similarity, then from this we can imply if we given enough image input of the person, then we're able to capture completely 3D of the person. Okay, all right, and now that's we talk about no adaptation. But let's see what happened if the adaptation case. With adaptation, that means given this, and we detect the object, similar object, we do the tracking of that object, and we try to find the next object based on the adaptive feature. Okay, and what you see over here is a given input and able to retrieve a lot of very ambiguous information, for example, this and that and that. Okay, and with given single input, we're able to identify about 495 similar objects. And now that's what I show you with the big database. And now let's look at the next one is about the aging process. Another interesting thing is to study about the aging phase or aging object, because in time the object can be degrading, depend how degrading it is and whether our algorithm able to detect it or not. Okay, in this case we do this study, we extract just a single image we use in the an officer and gentleman movie, this object. Then we're going to run the movie, the database of Pretty Woman is 8 years later, and that means Richard Gere aging about 8 years later, and see if it can find the right person. And surely enough, with this input, and able to identify the same person, Richard Gere, with no mistake. Okay, and he found about 70 similar objects. Okay, and what it's telling you is that our bioinspired technology able to tolerate certain aging object. But remember, it completely aging, it wipe out on the feature, no way we can do it. But as long as it remains certain feature, our bioinspired technology is capable to detect it and identify it. And but another thing is, as we mentioned earlier, we have the partial face recognition. If you use the part of less aging process involved, and you're able to retrieve the correct person. And that's all I want to give you demo today. It's a little bit long, but I try to capture it. And thank you for listening.